Hello students, we'll discuss now the line currents, line voltages, phase currents and phase voltages in star connection. Star connection, line voltages, phase voltages, line current and phase currents. Okay, before going to explain that, okay, see, as I already said, you can see these points. This is voltage of first phase. Let us take this as R phase. Let us take this as, I am assuming the phase sequence as RYB. Okay, the phase sequence will be what? Clockwise direction. RYB. Now, RYB. Each angle, each phase to phase. Let us take this as VY. Let us take this as VB. If I am measuring from phase to neutral, this will be what? VRN, VYN, VBN. Okay. So this will be VR, VY and VB. From this VR to VY, we get an angle of 120 degree. From VY to VB, we get 120. The same way we get 120 here. Hope you understand this point. Now this is the voltage phasors. Voltage phasors. If I take the lagging load, remember this guys, lagging load. What is the lagging load? Always current I lags the voltage. Current I lags the voltage by an angle of phi. For example, if I take the voltage references, this is the voltage phasor. Current always lags the voltage by an angle of phi. If I take this as the voltage phasor, current I is always what? Lagging. Current I is always lagging the voltage. Okay. So this will be the R phase current. Hope you understand this point. In the same way, for the V phase current, for the V phase voltage, the current will also be lagging in nature. Okay, this will be the I phase current. In the same way, so this will be the V phase current. So this VR and IR are lagging exactly by an angle of phi. This will be also angle of phi. This is angle phi. Hope you can see in this figure B. So this is the star connection. This is the star connection phasor diagram. So what you can observe here is, in star connection, whenever current is flowing in the phase, also flowing in the line also. In star connection, whenever current is flowing in the phase, is also flowing in the line, is also flowing in the line. Okay, the three lines or phases, three line or phases currents are IR, IY, IB, comma, voltages are if it is flowing from phase VRN, VYN, VBN. It represents the three phase voltages. These three represents the phase voltages. Okay, these three represents the phase voltages. Okay, now the voltage between any line and a neutral, the voltage between any line and neutral is voltage between any line and neutral is represented by what? VRN is equal to magnitude and phase angle, magnitude and phase direction. Let us consider this as the reference phasor because we have to consider one voltage as a reference phasor. So let us consider R to neutral as a reference phasor. If we consider R to neutral as a reference phasor, then what I get here is assume this is what VRN means. Then what about VYN will be? VYN will be magnitude and how much phase angle it is moving now with respect to R. So this VR nothing but VRN. This VRN, this is VYN, this is VBN. VRN to VYN, how much is the phase angle now? Phase difference is 120 degree. Is it plus or minus? Minus 120. So here it is VYN is equal to V at an angle of minus 120 degree. Okay, in the same way, what about VBN? VBN is nothing but V at an angle of minus 240 or plus 120. We can write anyway minus 240 degree. Okay. If I want to find the current flowing through the R phase, if I want to find the currents, you know how to find the currents then? Currents are nothing but, apply Ohm's law here. Current flowing through the R is nothing but voltage across the R phase divided by the impedance. Voltage across the Rn divided by impedance. While we take the impedance, we should also consider the phase. So this is nothing but the impedance phase angle. Impedance phase angle. So what is VRN? VRN is nothing but V at an angle 0. V at an angle 0 divided by Z at an angle of phi. So we represent this as magnitude with V by Z and phase angle will be, this denominator phase will change to numerator means we get minus phi. In the same way, what about Y phase? If I consider Y phase, nothing but Y phase is nothing but VYN divided by Z at an angle of phi. Okay, Z at an angle of phi. What is VYN? VYN is nothing but V at an angle of minus 120 degree divided by Z at an angle of phi. If this Z denominator will change to numerator means it will be, let us consider the magnitude at an angle of minus phi, sorry. Anyway, we can write here minus phi minus 120 or minus 120 minus phi. So we get here minus 120 minus phi. In the same way, what about current flowing through the B phase, VBN upon Z at an angle of phi. How to represent this one? V at an angle of minus 240 degree divided by Z at an angle of phi. What do we get here? V by Z magnitude, and the phase angle will be minus 240 degree minus phi. So these are the three different currents, okay, equal in magnitude and have a phase difference of 120 degree each. So the disposition of these vectors are shown as in the above figure. Sometimes the fourth wire, called a neutral wire, is run from the neutral point if the source is also star connected. Okay, whatever we are doing now is the load side. Okay, if the three lines are balanced, if the three lines are balanced, the three lines, that is R, Y, B, both are balanced. Three wires are balanced. Then the current in the fourth wire is zero. Then the current in the fourth wire. What do you mean by fourth wire? That is neutral current. Current flowing through neutral will be zero. Okay, removing this connecting wire between the source neutral and the load neutral, therefore not going to make any change in the condition of the system. So if we remove the neutral on the source side and load side, if we remove the neutral point, the fourth wire, then nothing will change more effectively. So the availability of neutral wire makes it possible to use all the three phase voltages as well as the three line voltages. The neutral is grounded for safety reasons, that's it. It makes no difference. Okay, in case of star connection, whether we change the, whether we put the neutral on grounded on both source and neutral, source side and load side, nothing will change because the line current and the phase current both are same in case of star connection load. Remember this point very carefully, star connection. And coming to the voltages, line voltage is equal to so voltage across each phase of the delta connected source is different, but in case of star connection, line voltage is equal to root 3 times of the phase voltages. This is very important. For star connection, line voltages is equal to root 3 times phase voltages. Line current is equal to phase current for star connection. Okay, for delta connection, this is reverse. For delta connection, what we have here, line voltage is equal to phase voltages, whereas the line current is equal to root 3 times of the phase current. You have to remember this formula, very important. Okay. Thank you.